Okay. Good morning, guys. I want to believe that this morning's class we come with a difference and we'll be able to make use of our time accurately without having to bother ourselves with the stress of noise making. As soon as you enter, I would advise that you register your presence through the chat box. Just register your presence through the chat box so that we can have a picture of people that are already in. My name is Oladapo David Ifeoluwa. I'm a lecturer at the university, Adeleke University Ede. This is absolutely a class that comes as a result of the current ongoing pandemic, coronavirus. Don't mind me, COVID-19. Okay, so we are leveraging on online class so that we can engage our students even while they are at home. Last class, we examined first principle in differential calculus. I told us that this is very important for anybody that need to walk through calculus, differentiation as it were. And I remember I showed us some examples, about 1, 2, 3, 4 examples. If you are watching this video for the first time and you would like to get back to that, you can check my YouTube channel. It's actually there, our first class. So this is our second class, and today we will be looking at one or two things. Some of them is, number one is we'll consider Nomina Rule. I actually showed this particular principle to you last class. If you could remember, I showed something like this to you last class, telling you that this looks like the shortcut to differentiating equation, a function. It's like a shortcut that is very beautiful. However, it might be difficult for you to always say this is the principle you want to use. Sometimes there may be requirement from from me or from the question that you should use first principle. That's why we dwell so much on first principle in our first class. So today we'll be checking this nominal rule, we'll be proving it, and probably what we will still have to use is the same method I taught you last class, talking about first principle. After this, we'll look at trigonometric functions, how to differentiate trigonometric functions. We will consider that. We will look at how to differentiate sum when you have sum. Functions are in sum, how to differentiate them. So these are one or two things, and we'll see examples around them. If you have any question or whatsoever, please do well to ask question through the chat box. I will answer all questions. And after I'm done with the class, I will unmute everybody so that you can also ask questions. So if you have any question, you can either chat me straight, I'll be checking my chat box, or you find a mean, you wait and write it somewhere so that you can ask. There will be a room to ask questions at the end of the class. If you're already in, it will be safe you register your presence through chat box. Okay, to today's class, consider this equation. If y is equal to ax raised to power n, when you differentiate, what you are meant to have is, like I told you in last class, that this n multiply what is in front of this place, and you just remove one. If that is a basic principle, like I told you the last class, is fast, is simple, and straightforward. So it's more or less like a shortcut that you know that when you are differentiating ax raised to power n, you are meant to have The n is multiplying the coefficient of x. So that gives you NA. Then you remove 1 from n. If you are differentiating the second time, that means, you have something like n minus 2 up here because it's not like 2 times. Then you now multiply n minus 1 by n. That is the way it works. But let's prove this so that we can know it work across all board. So that's what we want to consider now. That's what we want to consider now. Now I say proof y is equal to ax raised by n. Now remember first principle that I taught you, that's what we'll be using to prove it. The first step says add the y to y and add the x to x. Okay, it says add the y to y and add the x to x, just like I've always told you. Now, if you add this to the two sides, you will be left with the y, a into, you have y plus the y, a into bracket x plus the x over n. Now, let's transfer our y to the other side. And like I told you, if your y is moving from left-hand side to the right-hand side, the sign will change from positive here to negative here. Now, you now have a into bracket x plus dx all raised by n. What is your y? Your y is actually ax raised by n. And that's what we have here. Now, can we try to do something around here? Now, if you consider this part, we only bring out x as something that is common to both of them. Now, check this out. X times 1 will give you x. When you multiply x by dx over x, x will cancel this x, then you have your dx. What does that mean? That shows you that what you have here is what you still have here. I don't know if that place is correct. I'll take that place again. You have a multiplied by x into plus dx raised by n. Now we are solving this. From this, we can have this. And how does that one possible? Like I told you in class, if you could remember, I said, if you can't find your way forward, can you find your way backward? As long as you can find your way backward, you are covered. So in this part, let's see if we can find our way backward. Like if you multiply x by 1, it gives you x squared. If you multiply x by dx over x, x will absolutely cancel x, then you have dx. So that means this x plus dx raised to power n can also give us x into bracket 1 plus dx over x all raised to power n. That's how we have this equation, then minus ax raised to power n that we had like beginning. Now, considering that this x is not standing alone, but actually is raised to power n. So we bring it out. So we now have ax raised to power n. Now open, you still have your big bracket 1 plus dx over x all raised to power n. Normally this x is actually in this big bracket. So this x is raised to power n as this one is also raised to power n. That's why we bring it out. Absolutely. If you have questions, don't forget that you can ask questions via chat box. Okay, now having said that, if you now apply what we call binomial expansion, we had this so very much last semester during our Math 101, binomial expansion. That's one of our last topic that we consider. So I wouldn't want to stress myself on this. Now, when you open this using binomial expansion, you have 1, then you have n dx, is actually raised to power n. If it were to be 2, then it would have been something different. Now you have that n dx over x plus n into bracket n minus 1 d square x over 2x squared plus, now let's say you can have something like, if you are going for third, you have something like n into bracket n minus 1 into bracket n minus 2 d cube x over 3x cube. That's what you have. I'm sure so many of you will remember that now, that if you are doing binomial expansion, you have this one is standing alone on its own. Now this is the first one. That's why you have x. This is the first one. This one is standing alone. This is what we are expanding. Normally 1 raised to power anything is still 1. So we are expanding this, and as such, you have n dx over x plus n into bracket n minus 1 d square x over 2x squared. If you are going to 3, then you can have n into bracket n minus 1 into bracket n minus 2 d cube x over 3x cubed. That's what you'll be having. But for the purpose of this class, we'll just leave it on 2x squared plus dot 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 and minus our normal minus ax raised by n. Don't forget, this is more or less like our y. This is more or less like our y. You remember this y, so it's still coming alone. Now, when you try opening up the bracket, if you try opening up the bracket, you know this ax raised by n is actually multiplying everything here. So that's what we are doing now. We are trying to already we are trying to, the focus here now is we are trying to multiply ax raised to power n with what we have here. That's what we are doing. We are trying to multiply ax raised to power n with what we have here. Okay. Okay. All right. It's as if so many people are just joining. If you have missed the early part of the class, when I upload it on the YouTube channel, you will be able to pick it up. So let me start from this part. I had covered a very important part. If you have any question, please, you can answer through chat. If you have any question, you can answer through chat. If you have any question, you can answer through chat. You can ask through chat box. I will answer all questions at the end of the class. I will answer all questions at the end of the class. I will answer all questions at the end of the class. So just follow the class and ask questions through chat box. At the end of this class, I will unmute everybody so that you can ask your question. You are all welcome to this webinar, this online class. I had started not knowing that a whole lot of you are on waiting in the waiting room, but now obviously everybody should be in now so that we can okay, so let's move straight now. We in the last class that we had, I remember sharing with us the purpose of shortcut. I remember showing you something like this, that if y is equal to ax raised to power 9, if y is equal to ax raised to power 9, you can easily multiply n by a. That's actually multiply a by x. If you by n, sorry, so that you have na and remove 1 from n. That was the shortcut I told you in last class. You remember I did that. However, this rule, as much as it's beautiful and it works fine, first principle is very important, that there are situations whereby that is all you will have to do. Now, there are times, in fact, it will be safe for me to tell you and for you to note for a purpose that this is one of questions you should look out for in either your mid-semester test or your exam. Should look out for this question, whereby you will be asked to prove this nominal rule. You can be asked to prove nominal rule. This is the rule. This rule works absolutely fine. It works absolutely well. y is equal to a. Okay, y is equal to a x raised to power n. Normally, what you do straight is you just say n multiply by a, then gives you na, then you remove 1 from n. With that, you are good to go. However, you can be asked to prove this rule, how it works, if actually it works at all. That's what we are doing now. That's what I want to prove to you, that using first principle, you can actually prove that when you apply it this way, it will work. As soon as you enter, you can actually register your presence by writing your name, your department, and your matric number. Your name, your department, and your matric number. Okay, Ifeoluwa has actually registered attendance. Others can equally do same. Okay, now let's look at this straightforward so that we'll not waste much of our time. I want to manage time as much as possible today. Y is equal to a x raised to power n. We want to prove it. And how do you prove it? You apply first principle. And you remember that the first rule I told you, the first step in first principle is what? That you add the y to y, and you will add the x to x. Now, using that, you considering that method, when you add the y to y and you add the x to x. Now, having added that, you can just open your bracket. You know your y, when your y move from left-hand side to the right-hand side, the sign changes. So now it's changing from from positive to negative. That's why you have a into bracket. You know, this one is standing as it were, and your y. Now, what is your David? Mo wà ní class o, má pè mí, mo wà ní class David. Mo wà ní class David. Má pè padà. Mo wà online class. Now, when you consider y, what is your y? Your y is actually ax raised to power n. Some of you will begin to remember now. Okay. All right. So like I was saying, let me quickly share my screen back. Sorry, a call actually came in. Okay. Are we together? If you are with me, kindly say I. Let me just wait and be sure you guys are with me. If you are with me, kindly say I. Say I if you are with me. Let me be sure I am not alone on this. Say I if you are with me so that I can continue. Just say I using chat box. Say I using chat. Okay, very good. Very good, very good. So we can continue. So A, like I was saying, that when your y move from the left-hand side to the right, then you have it as minus y. And what's your minus y is minus ax raised to power n. If it's minus ax raised to power n, can we do something here briefly? You remember when we were in class, I told you that if you don't understand how to move forward, do you understand your way back? If you don't know how you get to where you are, can you try to trace your movement back to where you used to be? Now, considering that analogy, I would like to show you something here. How did we move from this place to this place? Now, look at this, everybody. X multiplied by 1 will give you x. When you multiply x by dx over x, you know, x will cancel x, then you have your dx back. Did somebody get that? You can give me nodding, at least I can see you. Give me nodding so that I can be sure you're actually following. That, you know, when you multiply x by 1, it gives you your x back. If you multiply x by dx over x divided by x will give you the x. So that's what we are doing. We just bring out x so that we can separate it and move forward. So that's what we are doing here. Now, looking at that, you will agree with me that x here is still raised to power n. Absolutely. So that's why we just bring that xn back here. That's what we did here. Okay, let me see if you have any question. Is there anybody? You can raise up your hand if you have a question. I will unmute you. You can raise up your hand if you have any question. Probably you didn't understand how I arrive at what I'm doing. Okay, for now, it's still very fine. Okay, so that's what we did here. X multiplied by 1 give you x squared, and hold on, please. I'm trying to check. Okay, so let's continue, please. So now you just have one axn times 1, coming from this part. You have your xn now out, and this one stands as it is, and this one is like this. Now remember binomial expansion. I taught you binomial expansion as part of towards the end of last semester, if some of you can remember binomial expansion. So that's what we applied here, using binomial expansion to expand this. What we have 1, then you have the first one. Now you have n dx over x. The next one will give you n into bracket n minus 1 d square x over 2x squared. Now if you are going to have the third one, what do you have? You have n into bracket n minus 1 into bracket n minus 2 d cube of x over 3x cubed. How many of you remember that? So that's what you have using binomial expansion to expand this. This to expand 1 plus dx over x raised by n. We are expanding that using binomial expansion. You have 1 plus n dx over x plus n into bracket n minus 1 d square of x over 2x squared. If you want to move a step further, you have something like n into bracket n minus 1 into bracket n minus 2 d square of x over 3x cubed. That's what you will have. Now, looking at that, you can move forward now. Let's now open this bracket. You know that this is actually multiplying this, taking a clue from this part. A is multiplying x, so axn is multiplying this. This is what we expanded. Now, we want to now multiply axn by this. Now, if you are doing that, you agree with me that ax raised by n multiplied by 1 will give you this. When you multiply this by this, you have this is your axn, then you have this. Now, when you multiply this by this one, this is your n into bracket n. However, this is your ax raised by n. That's what we did there. Now, this minus ax raised by n can now cancel ax raised power n. Did you get that? And from this place, you can now have ax raised power n minus 1 n dx. I'd like you to check your notes and correct this part. This part is only ax raised power n. Correct this place and add minus 1. It's now ax raised power n minus 1. Check this part and correct it from your note. Now, plus n into bracket n minus 1, ax now, n minus 2, it's more or less like you are dividing by, you divide by x, you divide by x squared, like stuff like that. So ax raised to power n minus 2, d square of x. Let me take this part again so that I can be sure you guys are following. Adragbemi, which part are you finding difficult to understand? Let me see if I can unmute Adragbemi so that she. Hold on, Adragbemi. Let me unmute you so that you can ask your question. Adragbemi, I'm coming. Adragbemi. Okay. Adragbemi, you can talk.
Okay, so from that, a open brackets x plus dx, then raised power n minus ax n. Ax raised power n.
Come again. Where are you saying you didn't understand?
From that a open bracket
1 plus.
Okay, the place we expanded, that will put that 1.
Now, are you saying you don't understand that?
Not expanding binomial expansion. No. The first place where we put the 1.
Oh, this place before binomial expansion, right? Hello? Adura, are you talking about this place?
Yeah. Hello? How did you get that 1?
Wait, are you talking about this place, Abi? Should we pick it from here?
Before binomial expansion, how did you get the 1?
Yes.
Yes, sir.
Yeah, exactly. Good.
Sir.
You could remember in class, I taught you guys that if you can't find your way forward, if you can't find your way forward, you should be able to find your way backward, right? Okay, can we do this together now? X multiplied by 1. What will it give you, Adura?
X.
So you have this X back, right? Are you following me?
Yes, sir.
Good. X multiplied by dx over x. You know, x we cancel x, right?
Okay.
So you have dx. Did you get that now?
Sir. Yes, sir.
Did you get how we got here now, right?
Yes, sir.
So, and I think with that, everybody can understand that too. You can reply through chat, everybody, so that I can be sure you understand this part now, everybody. You understand this, Adura, then you understand this. Yes, then you understand the binomial expansion, right?
Yes, sir.
Good. So we can continue, right? From this place.
Yes, sir. Yes.
Can you see my cursor, my pointer? Can you see my pointer?
Yes.
Okay, so you understand it to this point?
Yes, sir.
Let me check if another person is finding. Please, sir, before the binomial expression, it's not clear. I think I've explained that now, Bamiji. I can't start all over again. You may have to watch this video again if you didn't understand this part. So we can move forward. Okay, so now if you have another question you can ask, I will answer. Now multiplying ax raised to power n by 1, you have ax raised to power n. Multiplying ax raised to power n by this is this, then you still have this. Multiplying this by this, you have this, then you have this here. So there's no problem with that. Now, let's just go straight that. Minus ax raised to power n, we cancel ax raised to power n. Everybody, did you get that part? When this cancel this, then you are now left with ax raised to power n minus 1. I ask you to check this place in your note. It's actually ax raised to power n. You add minus 1. Omojola, you are just laughing. I'm not sure you are following. Omojola laughing. Ifeoluwa. Okay. So ax raised to power n minus 1 dot n dx. You know, it's more or less like your x now coming. So you now have x raised by n minus 1, you know, it's like you're multiplying n with this. Now, when you have that here, you have x n raised to power minus 2, you know, you don't have x squared again here now. You know, just with the idea, just remember the concept, like you're not turning to multiply. You want to turn it to multiply, it turns to like x raised to power minus 1. So x raised to power minus 1 multiplied by x raised to power n, what will it give you? It will give you x raised to power n minus 1. Did you get that part? Now look at this place too. So x raised to power minus 2 multiplied by n, it will give you x raised to multiply by x raised to power n. It will now give you x to power n minus 2. So that's how you have this, and you don't have x squared here. You don't have x here. Did you get that part, guys? Okay, I want to believe you got that part right. Okay, so the next move, let's divide all through by the x. So if you are dividing through by the x, you agree with me that this one remain, because you now have, now check this part. Check this part now. Check this part. If you are dividing through by dx, so dx, we cancel dx here. So you have a n x raised by n minus 1. You know, dividing through by dx now, everybody. Dividing through by dx. You have, okay, let me unmute Praise Oladimoke. Hello, Praise. Hello, Praise. Are you there?
Yes, I'm here.
Okay, are you following me? Did you get this part, this last part?
Yes.
Okay, good. Dividing through. No, this last part. Dividing.
No.
Okay, now follow me now. Wait, follow me here. Follow me here. Dividing through by dx. We want to divide through by dx as usual. That's the next step, right?
Yes.
So, you know, the x, we cancel the x here, right?
Yes.
So if it cancels, what are we going to be left with? We'll be left with an or na x raised by n minus 1.
Yes.
Are we together? Now, hello guys, this class will end in 10 minutes time. As soon as it ends, I will start another class and send you the link on your WhatsApp. This class will end in 10 minutes time. I will send you another link so that we can continue. We don't have more than 40 minutes access. We are almost done with 40 minutes. Are we together? Can we continue now? So now, when you divide the x here, you have ax raised by n minus 1 plus n into bracket n minus 1. When you divide the x here, what do you have left? Praise. Tell me what you likely have here. Excuse me. Oh, I already mute you. Excuse me. Praise. Praise. Hello, Praise. Hello, Praise. Are you there? Hello, Adura.
Sir.
Good. Can you tell me what you have here if you divide by dx, this part? What are you going to have?
If we divide by dx.
If you are dividing by dx, we are dividing by dx. What are you going to have? This place alone. You know, we have divided this place now. We know there won't be dx again. But here, what are we going to have?
Ax.
Mm-hmm.
Yeah, that will be ax raised to power n minus 2, then dx.
Very good. Very good. I'm happy now. That's the idea. You just remove just one dx. So that's what that led us to this result. We now have nax raised by n minus 1 plus n into bracket n minus 1 ax raised by n minus 2. So you have just one dx left. That's what we have there. Now let your dx tends to 0. So if dx is tending to 0, everything here will be what? Will be 0, because the 0 multiplied by everything here will be 0. That's how you now have nax raised by n minus 1 plus 0. And your dy dx will be nax raised power n minus 1. That's how you have your dx. Dy dx to now give you na raised by n. And now hear this. This formula can be used directly without necessarily going through the stress of first principle, except you are asked to do so. You understand now? If I give you a function and ask you to differentiate, you can apply this method unless I ask you to use first principle formula. You can be sure you will see something like this. We will need to prove this. We'll need to prove it out. Hello guys, can we move to next slide now? Now, trigonometry function. Trigonometric function. Now, how do we differentiating trigonometric function? That's what we are looking next. Differentiating a trigonometric function. The following trigonometric identity. Now, I need you to, for engineering students, I took them Math 151 last semester, and they will understand that it's very they will understand that this rule, just try to memorize this rule, that sine A plus sine B is equal to 2 sine A plus B over 2 cos A minus B over 2. Sine A minus sine B is equal to 2 sine A minus B over 2 cos A plus B over 2. 3. Cos A plus cos B will give you 2 cos A plus B over 2 cos A minus B over 2. And 4. Cos A minus cos B is equal to minus 2 sine A plus B over 2 sine A minus B over 2. Now the idea here is simple. The idea playing out here is simple. Just understand this concept, memorize them, and apply it. We will need to apply it when we need to start solving, trying to differentiate, maybe differentiate y is equal to sine x, differentiate y is equal to cos x. So these are the things we will likely need. Just know that from trigonometric function identities, that sine A plus sine B is actually equal to 2 sine A plus B over 2 cos A minus B over 2. Let me give you the concept here. If it's plus, you know, you have plus here, you have minus here, and it's always sine and cos. If it's minus, you have minus here, and you have plus here. However, for cos, if you are adding cos A plus cos B, the answer remains cos. But you have plus here, you have minus here. If you're now having cos A minus cos B, then you have sine all through minus 2 sine A plus B over 2 sine A minus B over 2. This is a concept that you just have to memorize that will be very, very useful as soon as we start to differentiate. Now, to differentiate trigonometric function, we use the method of differentiation from the first principle. And in the process, we shall use some of these identities listed. So you see now, if you are differentiating trigonometric function, what do you use? You will use first principle also. And in the course of using first principle, you may need to apply these trigonometric identities in order to be able to solve your equation. Next slide. Now, let's check this example out. I hope we'll be able to solve this example before our time is up. I hope we'll be able to solve this example before our time is up. Okay. Solving y is equal to sine x. So if you are asked to differentiate y, when y is equal to sine x. Now, follow me on the same method we are fond of using, that you add the y here, you add the x here. So what would that give you? You now have dy to be equal to sine x plus dx minus sine x, because your y, when it moves here, it turns to minus sine x. Now look at this from last rule that I gave to you. Let's say this is now your sine A, this is now your sine B. That's what we are having here. Let this be your what? Your sine A, and this be your sine B. We have just 3 minutes remaining, and I want to try if I can finish the explanation before the end of the 3 minutes. Now, let's follow that. Now, remember that sine A minus sine B is equal to 2 sine A minus B over 2 cos A plus B over 2. What is your A now? Your A is x plus dx. So that's now, this A now is x plus dx. What is your B? X. So this is your x. Is somebody following me? What is your A here? X plus dx. What is your B? X over 2. That's all. Now, if you can apply it, this thing is very simple. You just need to understand the concept. Are we together? Okay. So, okay, let me ask. Promise. Hello, Promise.
Sir, yes, sir.
Good. Are you following me here?
Yes, sir.
Okay, you understand this concept here, this place?
Yes, it
Very
was
good.
that first one that I did not understand.
When you just watch the video again, or you might, after this class, you understand, right? So let's move forward.
Okay.
Okay, so now, when you know that x will cancel x, so you are left with dx over 2. Now this place, x plus x will be what? 2x plus dx. That's all you have. So you now have 2 sine dx over 2 cos 2x plus dx over 2. Now let's divide through by dx. This place you really have to be careful. I think at this point in time, let me pause the class here so that we meet immediately. I will fix next class for 11:50. Next class will be 11:50. That will be the time I'll fix on it so that we can all come back to class by 11:50 and use the last section of 40 minutes that we'll be having. However, Promise, quickly ask your question in that 1 minute and let me see if I can answer.
The binomial expression.
Expansion, this place.
Expansion. Yes.
Check it out.
Binomial expansion.
Is it the binomial expansion? You didn't understand this part?
Yes, that place, yes.
Okay, so I said it's just that you have forgotten binomial expansion, right? So you may need to take your book, are you getting me? And read and understand how binomial expansion works. The whole idea is, look at this place. This is x, right? This is 1.
Yes, sir.
This is x squared. This is 2. The next one will be what? 3x cubed. Did you get that part? Now look at the top here. This is 1, Abby. So you have 1 here. This is 2x squared. You have square here, right? So when you get to 3, what will you have? The cube x, right? Now look at this part. You have n only here. The next one was n minus what? minus 1.
Minus 1.
Then the next one will be n into bracket
N
n
minus-
minus 1 into bracket n minus 2. You remember that n did not leave. N minus 1 did not leave.